test question number 3 from 2015. Gives us the chart at the top and tells us that we want to estimate the derivative of velocity at 16. So if you remember, derivative means that is another word for slope. So we want to get the slope at 16, which is between, at time 16, which is between time 12 and time 20. So we are going to do the slope formula for this. So we would get 240 minus 200 all over 20 minus 12. Right there is your answer. You do not have to simplify that. If you do simplify it, you would get 5. Now, this particular problem does not say use units, but if you do, you need to know that the top is the meters per minute. So that up there with the Y's is meters per minute. And then on the bottom is the T, which is also in minutes. So that's meters per minute, which you could also write as meters per minute squared. So there's your answer. And if you solve that, you end up getting 5 meters per minute squared. So that's part A. Part B says, using correct units, explain the meaning of the definition of the integral from 0 to 40 of the absolute value of velocity. Now that's a big deal, absolute value. Hopefully you realize that the integral of absolute value is total distance. And then it says approximate the value using a right-Riemann sum with 4 subintervals indicated by the table. So for this first part, we want to know what this means, and we have to use correct units. So integral means area. So we want to get this absolute value is going to be the total distance that Joanna I don't know if that's the right way to say her name, travels in. Now, if you take this base times height, your height's meters per minute, your base is minutes. So when you multiply minutes by meters over minutes times minutes, those minutes reduce out and you're left with meters. And that would be from t equals 0 to t equals 40 minutes. And yes, you got to have the t part in there. So that would be the first part of the answer for part B. That would be worth 1 point. And now we got to do Riemann sum. So you can make this graph more accurate than if you want. I don't really care. We are going out here to 40. This is 0, and then somewhere in here we have 12, 20, and 24. And now we're doing a right Riemann sum. So I'm starting out here at the right where this is 150. So when I do this, I'm going to say that the integral from 0 to 40 of the absolute value of v of t dt is going to approximately be, and I'm going to do that first one. So between 24 and 40 is a total of 16. So your base is going to be 16, and then that's going to be times the absolute value of 150. And those, I have absolute value signs. 16 times 150 plus, now the distance between 24 and 4 is 4, so that's going to be 4 times the absolute value of negative 220. And I know in the graph that would actually be below the x-axis, but I really don't care. And between 12 and 20 is 8, so that's going to be plus 8 times the absolute value of 240, because I'm doing the ones on the right. And then that's going to be plus, the distance between 0 and 12 is 12. And that's going to be 12 times the absolute value of 200. Now, I am not sure if they would count that right because of the absolute value thing. So I would definitely make sure I rewrote it as multiplication with especially this one being positive 220 times 4. But when you get done with all that, that comes out to be 7,600 meters. Okay, so the total distance that they traveled would be 7,600 meters. And if I were you, I would write it again from t equals 0 to t equals 40 minutes. I was supposed to say minutes down there at the bottom. So that's the answer to the second part of B, and that's worth 2 extra points right there to be able to do that. We're going to go on to part C. Part C says Bob's riding a bicycle along the same path. Bob's velocity is modeled by that function for B, where t is in minutes and b of t is measured in meters per minute. So again, that thing given to you is a derivative, okay? So b of t, this function is a derivative because it's meters per minute. That's a derivative. Find Bob's acceleration at t equals 5. So what that means is we want to find b prime of t. I'm going to get rid of that line. So we want to find b, our thing we want to find is b prime of 5. So before we find b prime of 5, we're going to find the derivative of b. So b prime of t is going to equal 3t squared plus, oops, sorry, not plus, that would be minus 12t, and that'd be the end. So what we want to do now is we want to do this b of 5 is going to equal 3 times 5 squared minus 12 times 5. Now again, that right there will give you your answer. Now this, does this say to do in units? This does not say units, so you do not have to actually give the units. But if you did, again, your y value, it tells you right here that your y value is meters per minute, and your t value is minutes. So that's just like the one above. This answer would be meters per minute squared if you're going to put it on there. You do not have to. And if you went ahead and worked the whole thing out, it would be 15. You do not have to do that. This thing right here would be good enough for your answer. And the last problem is D. Based on the model of B from part C, find Bob's average velocity during that time. So that's the average value theorem, the average value theorem. And it says from 0 to 10. So this is your A, this is your B. I hope y'all remember that the average value theorem is 1 over B minus A. So that's going to be 10 minus 0 times the integral from that same 0 to 10. And then we're going to plug in our function, which is going to be t cubed minus 6t squared plus 300 dt. Okay, I don't have a lot of room to write on here, so there's a thing at the bottom of my screen, so I can't write under that where your screen is blank. So then when we do that integral, we're going to get 1 over 10 times the integral of t cubed is t to the 4th over 4. The integral of negative 6t squared is negative 6t cubed over 3. And then plus 300t and that is going to be from 0 to 10 here. Okay, so when we plug in our 10, we're going to have our 1/10 in front of all this. And then we would have 10 to the 4th over 4 minus 6. Actually, we could just change that 6 to a 6 divided by 3 over here on the left. Reduces. This thing reduces to 2, so we can say minus 2 times 10 cubed. And then plus 300 times 10, which is going to be 3,000. Okay, so again, that's fine for your final answer. If not, you're going to end up getting, if you want to keep going, that would end up being 350. Now, we are doing the area. We're doing the area, so that's your height, and that's your base. I'm sorry, this is velocity, so it's going to stay this same thing, my bad. So this would be 350 meters per minute would be your final answer. So that's the end of that question, and if you want me to do more, please let me know.